Ladies and gentlemen, would you please welcome Michael T. Jones.
Thank you. Thank you. Today we're going to talk about Google and the Geoweb. And in particular, the point is about the things that we're doing to create that and to help you create that. So we have some slides to show you. And let's take a look at the first one of those if we could. I just want to mention to start out with that we've had an interesting year. Not just us, but the Geoweb itself. Everybody geographical, everybody geospatial. And one of the things I mentioned that was a motivation for me when we started Keyhole, the company that became Google Earth, was that I wanted to have a tricorder of my own. And I think a lot of the applications people build using the Maps API are kind of like a tricorder. They're this embodiment of knowing something about places you don't know about and feeling like a little bit like you're a local when you're not. I love that. And so that's something we thought of, and the Star Trek tie-in is also relevant because last year I met the Gorn captain. I met the man who chased Captain Kirk there, and he's now retired. He's no longer a belligerent alien. He's a nice guy. He raises horses in a little bit northeast of Los Angeles, and he uses Google Earth. He sent us his fan mail. It's great. Today, though, we're going to talk about seriously what our mission is. So Google's mission is to organize the world's information and make it universally accessible and useful. And we take the universal part seriously, the organized part seriously, the useful part seriously. And one of the things we found out is that even if you can index all the world's information and you can give all the answers, sometimes just showing a list of web pages isn't really as useful as could be. You know, a list of where all the hospitals are when the baby's almost due is no good, right? A list of the closest hospital and a map of which way to go, that's really good. Right? So that difference is all about what we're about in the Google Geo group and the APIs and the tools and the formats that we build. I'm going to talk to you about that because I know you're building those very things. This geospatial future isn't something that we're building. We're kind of like the Home Depot. We've got a bunch of tools that you could use to build that future. I'm going to talk to you about those. So first off, I'd like to talk to you a little about the information itself. Some information realistically belongs on a page. You know, when I read Shelley's Ozymandias, I'm reading the page, and I see the face, the frown, the wrinkled lip, the sneer. You know, I can see that in my head, and I want to read the page. You know, Shakespeare's sonnets. Some things, like where the hospitals are compared to my home, that kind of thing, I want to see on a map. And some data maybe could go either place. Somebody mapped out the Odyssey and the Iliad on Google Earth this last year, and so you can go all around the Mediterranean and see where they went, and this is where the Medusa was, this is where this was. And it's actually pretty good, because if you're from Greece and you were reading the Odyssey, these places would make sense to you. I don't know if you ever read any like American Civil War history, but I moved to North Carolina as a child, and then I started realizing all those places are actually places. They weren't just names in a book. There was like the Guilford Battleground and this place and that place, Bull Run. There were actually places. There's like a Wendy's at Bull Run, you know. But it's also a history place, and I learned that. So some information I think really belongs on a map, some on a page, some can be either one. And what we want to do is to build a browsing environment where things can have their natural home, and then have the two modalities where you can see them in either way if it makes sense for you. An example of that would be the way that page browsers, or the normal web browser, the way that we actually make that useful. So what does Google do? Well, Google, people publish web pages, not Google, you, other people. We index them. We let people search against them. And then when they've done that, also those pages link against each other. That makes it a web. That's why it's the web. It's not because it's a browser that it's a web, not because it uses HTTP as a web, not because it has internet it's a web. It's because there's a bunch of pages all hooked together. That's what makes it a web. And so to do that for geospatial, we need the same things, but in a geospatial context. We need to be able to have a format like KML, something that we can put the content in. That's our HTML. We need some way to index that, some way to search that, some way to link between them, some way to attribute data so you can see where it came from. Those are the things we're trying to build, and you'll hear more about that today. On the KML front, it's a format we came up with. We gave to OGC, and you see on the bottom there that it's a OGC best practices. You'll see that Feed Validator now supports not just validation of GeoRSS and other formats, but also an Atom, but also KML now. It's becoming accepted. You'll see if you go buy a copy of Photoshop CS3, you can edit KML. Right? There is a web of documents being built, and we're indexing those. You'll hear about that today, too, in a few minutes. Now, the next thing I would share with you is this idea of connecting Users and developers. We did something very important. We launched at Where 2.0 just 2 days ago. It's called Maplets. You'll hear about that today, and you'll be able to chance to learn how to do that yourself. As the Google Global Developer Day has progressed to here, in several different countries, we've heard from our presenters that people in the audience built Maplets while they were in the audience. During the class on how to build a Maplet, people with Google Maps API sites built Maplets of their site that could then be published so that the #1 mapping site in the world, Google Maps, users of that could actually see your website's map data in that map. When they click on the icons, like the weather temperature, say, for a weather site, it goes back to your site. You can advertise there, do whatever you want. So that idea of discoverability, wouldn't you like Google Search to always have on every page, come to your site? Well, now Google Maps can say, come to your site. Give people data. Each data point is like a snippet of the value of your site. That's a big thing. And now we launched that. You'll hear about that. Here's an example. You go and you can add it either by URL or if it's in the gallery. And then here you have this geograph is now a Google, is a maplet. The guy did that just on his own. It's just amazing. So a lot of that today. I also want to stress the way we connect with users. We do international data. So this is not the Schiphol airport. If it looks like it, but it's not. Those are actually in the little red there. Those are women and children. There's push chairs. This is a little miniature city. This data is so fine. That's a sidewalk. Those are people walking. It's like a little miniature park. It's like Legoland. And you can see that kind of data for large whole countries. We've done local data in Google Maps where you can see buildings in 3D. We've made the little icons on the map clickable. We launched that on Tuesday, where you can see, like, if you go to Zurich, you can only see what subway lines it is, but train lines, you can see the schedule. So you can make the things. These are attracting users to this GeoWeb. This is something I think you may have seen. It's called Google Street View that lets you fly around a city and then pick a place and then look around in 360 and move around. That's what people think is like the edge of the possible. Now, we also do real-time traffic. We also let people build their own maps. This is a United States senator who took a trip back to Iraq to tour, took a congressional delegation back to Iraq. He met with constituents from his home state of Indiana. And then as he met with them, he made a blog, a geo blog, using Google My Maps and mailed that out to people. So that's a way you can tell stories even if you're a senator. We bought SketchUp and gave it away so that people could build their own 3D geometry. And people use that to build all the places they care about. For example, the Forbidden City or the Arc de Triomphe. We also, and I'm almost done, I want to share with you that there's an evolution in technology that's not unlike evolution in life, which is that, who's going to win? Well, the truth is you don't know the future, right? I mean, you're strong, but not strong enough to stand up to like the tidal wave. But if you see it coming, you run up the hill, even if you're weak, you'll survive, right? The ability to see what's changing and then react to that and then do something smart about that, that's who wins. And so I would encourage you to be that agent of change and that savvy person that says things are changing, but I'm surfing and I'm going to ride the wave. I'm not going to fight the wave, and I'm going to win. And in particular, when people see this Google Street View of, say, Union Square in San Francisco, I think maybe most people think, oh, that is just fabulous. But when I see it, I think, oh, that's just so, we're not there yet. I'm going to share my idea with you. When I see that, here's what I see. I see all the information of the world popping up on top of that. So that it's like I was a local. I would know where the store was. I would know what's going on. It would be live and real for me. We want to build that for the entire planet. We want to help you make a business out of that. And so the APIs you're going to hear about today tell you exactly how to do that. Now, to close, I have a friend, Alan Kay, whose team built the graphical user interface, the mouse, internet, Ethernet, everything. So he has this quote. He says, what's the easiest way to invent the future? So how do you predict the future? Well, the answer is you invent it, right? You don't guess the future, you build it. And I encourage you to build the future that you believe in and that you want to see. And please let us help you do that. And also, I thank Marge Simpson for using Google Maps and Google Earth also. Thank you. And I'm going to pass now to Ben Hagemark, who's going to tell you how to do some of these things. Thank you for your time.
Thank you, Michael. I'm going to dive right in. You're developers, so you want to hear about development techie stuff. So I'm going to give you an overview of the language called KML. KML is the way you paint on Earth and now on maps as well. KML starts with the place mark. I'm going to do one thing. I'm going to rip through a ton of stuff. I'm going to show you lots of angle brackety things. And then I'm going to show it to you how it looks in an app. So it's kind of a two-pass presentation. It all begins with a place mark. As you can see, it has a name, a description, and a point, as the name might suggest. Now, one thing about KML, as you just noticed, is it is an XML language. And when you paint a piece of KML onto Earth, it does three things. It puts a mark on Earth. It makes an indication in the panel. We'll see this. And you get a balloon. You've seen these kinds of things on his slides. I just want to make that point. And this previous slide, that is a complete, well-formed document that actually does something. You can copy-paste out of my slide, put it into a text editor. You can even paste it straight into Earth, and it does something. That's another point that I'd like to underscore here as well, that every single piece of KML that we show in these slides actually does something. So what else can you do? I'm going to show some things where we're going to be flying around. You can determine how it is you want your point to be looked at. If you don't tell us, we'll pick one for you. If you don't like that, you have the choice to determine that yourself. And you can see some of the fields you can control there, such as, of course, latitude and longitude. The world of Earth is, of course, 3D. So you can have all the full range of freedom for determining the viewpoint. If you don't like our icons, you can pick one of your own using language that looks exactly like this. We have rollover styles. When the balloons come up, you can do nothing and you get a balloon for free. If you put in some markup, we'll format it nicely for you, which looks like that. You can do some fancier things, such as styling the balloon. We're going to talk a little bit about that. OK, more than points, you can draw lines. You can make shapes. You can put shapes at 3D. You'll notice I'm doing my fancy PowerPoint highlighting here to show you that the elements that are used indicate 3D versus just 2D. 2D means it gets pasted on the ground, and I'll show you that in a second. Styling is something that allows you to paint your polygons and geometry whatever color you want. And we're going to get into some, I should step back one second. There'll be an advanced talk after this one where we're going to go into lots of interesting details of all these elements. If you draw just polygons and lines, you get nice geometry. It's nice for circling things, nice for making boxes. One thing we've added recently is textured 3D models. If you want to paste an image on the ground, you can do that. And within the past, since the Google Earth 4 release, which is now pretty much most of the field, this is a key element for making vast overlays, and we'll show that as well. You can paste things on the screen. OK, everything we talked about thus far is a single item. Of course, as you saw Michael's final display there, things are all over the screen. Well, how can you group your things? Well, of course, we have the folder mechanism, which does that. And as this indicates, the main elements that I've talked about can also be put into a folder and grouped. And folders, of course, can be put into folders, giving you hierarchy. A recent addition since last year was time. So not only does everything happen somewhere, but things often happen at some time. And how do you make that clear in your KML presentation? Well, you simply timestamp your data. In this case, I'm showing a time stamp on a place mark. So this particular point in time happened at that time, such as from a GPS reading. And I have a ground overlay that I'm showing as spanning a certain time. And I'll show you what that all looks like as well. Now, network link is my second most favorite element in KML. It's actually something that is extremely powerful, and I'm going to show a few slides of the variations of it. The simplest way you can think of KML is, a network link in KML, is as a way to divide your document into many documents. So for those of you who write programs in C or something, you have the include file. You can think of this as include. It just means get that KML over there. You think, well, why is that so interesting? There's actually a few variations on this. The one shown here is called view-based refresh. And what this does is, after motion has stopped, it kicks off a request. It fetches this link, and as you notice, this link is now a CGI script. That CGI script is passed some parameters that give the viewpoint of the user. That allows you to query a database, do whatever it is you're going to do, and return a result. Time-based refresh means you can set a timer. In this case, every 30 seconds, I'm going to call that script. That value can be set to whatever you like. It can be 2 days. It can be a few seconds, whatever is appropriate for your data, and that's one means by which you can animate your KML. And let me point out one more thing. You may have noticed that I slipped an HTTP into there. Everything that sits inside of an href can be at any network location. And by the way, foo.com actually exists. So we honor expiration in HTTP, and we can explicitly set it in KML. So if your data is delivered, has a certain expiration point, the network link will fire, and you'll get the fresh data, all up to you. And now we combine my favorite two elements in this entire language, and they allow a very sophisticated means of refreshing or fetching a network link. And as you see, the element used here is region. I'm going to talk a bunch about this in my second talk. But this allows you to basically trigger a fetch of the link as the user moves into a certain region. And what a region is a pretty open-ended, pretty powerful way to define a viewpoint. More on that later. I'll demonstrate that in a second. OK, on to a demo. One thing I'm going to do first is, if there's one and only one thing to remember about KML and where to get more information about it, it is that URL on the screen. If you have a laptop with you, you should maybe go there right now and take a look. We keep our official reference there. We keep a schema there. There's a link there to the KML support forum, which all of us who work on the team actually monitor that. So I'm going to be putting that slide up, that URL up quite a lot. So there's three things that I would like to get across about KML. First of all, the first point there is about it being a display language. For the most part, anything in KML actually draws something. It's not just a describe your data somewhere and hope some tool converts it into something and then you display it. This is actually the display language. The other is, and we will get to that in the following presentation, is where do you put these files? You can put them on your hard drive. You can email them to you. But as we talk about the web, of course, you can put files on web servers. And as I mentioned via the network link, that we speak the HTTP protocol just like any other browser. And it's a standard. We've been working with the OGC, and as Michael indicated, we are now a recommended practice. OK, on to the fun stuff. So let me just get a sense of how many people here have developed KML before. OK, not everybody. That's cool. OK, I'm going to start to show you a few things. And I have a little bit of time here. OK, I'm going to show you how I got here today. And I'm going to point out some of the KML elements involved. That's a place mark. The purple thing is a line string. The text is the label on the place mark. And I'm showing you also now the simplest way of making your data dynamic. And that is, on the left panel here, we have a bunch of place marks with icons and descriptions. And you can tour a folder. This thing at the top here is a folder of these marks. And all we're doing for driving directions is touring a folder. So one way to tour a folder is to visit all the place marks and show what things look like there. And one thing you also may have noticed, so you notice I'm coming in at that nice angle, and for each one the angle changes. That's simply doing the look at element for each one of these. When we compute the driving directions, we figure out which way you want to be going, and we set the heading, we set the tilt, we set the range, and of course aim you at the point that you want to see. OK, so at the one slide I mentioned that when you make a place mark, you're doing actually three things. And two of them are on the screen right now. One is of course, you mark a place. The other is you get an entry over here. And the final one is you get a balloon. Okay, and I talked some about, for example, I'm going to just use this one to continue. If you want to take away certain features, the user can come over here and turn things on and off. Maybe they don't want to see the whole trip. Maybe they just want to see the one icon. Maybe they want to see the whole viewpoint, but none of the data. Maybe you just want to see the line. That's that. And so here's another cool thing. So when I clicked on this, I flew to my data. And it might sound kind of dumb, but I feel the need to point that out. And there's a couple reasons for that. And that is, say for example, I just got lost. How on earth do I find my data? So there's two levels of that. One is once you've loaded it, you want to be able to get to your data, and you, the developer, want to have your users find your data and look at it the way you want it to be seen. And my colleague will be up shortly to talk about how you get that into your viewer in the first place. The way that I do it once I'm here is what I'm doing now is double-clicking on that left panel, and I fly to a bounding box of that data. If I wanted to, for example, this item here, it obviously has a fly to. By default, if we don't tell us how you want us to look at your data, we'll compute a nice bounding box. We'll have you looking straight down and north up. And maybe that's exactly what you want. Maybe you want something fancier like this for driving directions when you want to have the kind of the viewer's view of where they're going. Okay, so that's kind of a practical issue. I've covered now several of the elements that I talked about. I'm going to jump ahead a little bit. Let's do. What I'm showing now are some things from the developer examples on the web page that I indicated. So we show you how to make a place mark, how to make a balloon. And I'm going to do one thing that I think is actually a very neat feature. And that is you can come over to this panel, do a copy. You get some sort of KML. This is what I do. This is basically what I do all day long. Somebody out there in the world I see on one of the blogs, I see somebody's done some cool presentation. I suck it down, and I put it straight into a text editor. That's how geeky I am. So this is actually a very cool feature. If you want to, this is sort of the view source. It's kind of an eye chart, sorry about that. But if you have Earth running, you can do that yourself too. Just pick anything on that panel, do a right-click, copy, paste, and you can see what's there. Nothing mysterious there. And you can also paste it right back into Earth if you want to. But I'm not going to do that today. Okay, I'm going to show. This is the polygons primitive. It's very simple. In the XML slide, you saw a list of coordinates, and you saw, if you remember, an extrude element, which has the effect of turning your geometry into a box. You saw that you could color your geometry. And by color, we mean RGB and A. A is for alpha, and in this case, we've showing it with some amount of transparency. You can fly around to the buildings once again. In this case, it looks like we didn't pick any, the data itself didn't specify a bounding box, so we picked the one that encloses the entire data set. You can fly over and take a look at building 41. And hopefully all of you later today will be joining us right here, where I saw they were setting up a bunch of tents this morning. Okay, let's do a simple version of something that I'm going to show a very advanced version of. There's a little slider on the side of my, way down here in the lower left-hand corner, where I'm altering the transparency myself. You can do that in your KML as well. And what I'm showing here is an overlay, which is of an eruption on a volcano. And as we tilt around a little bit, we'll see that your overlay drapes over the terrain. So you give us the bounding box, and we'll follow the terrain for you. I mentioned that you could paint on the screen. Putting up the teeny tiny little crosshairs, if that's what you want to do. Screen space means that as the Earth moves below you, your image remains. One reason you might want to do that is to give a nice little logo to your presentation. Often people send their presentations, you turn it on, you'll see a logo in the corner. You can put it whatever you want. You can stretch it. You can put it any way you want. OK. All right, so thus far, that's all pretty basic KML. And there's one important thing to note about all the KML that I've just shown you so far, and that is that all of what you've seen just thus far works also on maps. And if you notice in our new documentation, we have a special link to show the samples file. You can just go click on it. It loads into maps, and you can look at all of these same things and how they look in maps. OK, I don't know how many of you saw the tornado that hit in Greensburg, Kansas recently. This, to me, is overall the coolest feature in KML, if you ask me. So what we're looking at here is a lot of imagery. And what you're seeing is, as I get closer, that I get more detail. So the ground overlay that I showed on the volcano, that was, maybe it was 1K by 1K, I'm not sure. This data, I don't remember the exact amount, but we have overlays that are in the tens of thousands of pixels on a side. We have data sets that are gigabyte-sized images. And if you think about that, how are you going to show that to a user? And we're going to talk in the advanced session about how we tile these things up and feed them to you. And the key point about this that I find pretty exciting is that as I switch this off, I'm showing you what we have right now in Earth as the base imagery. So what I'm showing you right here is KML. Now, the very cool thing about this is there's no magic server on the other side of this. There's no database. There's no scripting anything. It's just a pile of files. And using the region feature of a network link and some tiling software that I'm going to talk about later, you too, if you have a giant aerial photo or a historic map, if you go down into our layers panel, and if I point and click around down here, I can't show you that right now. This is the same technology. If you've seen the Rumsey maps, for example, the historic maps, he has, we're showing about 16 of his maps. He has, I've been to his house. He has quite the workshop where he has many thousand maps. And we're hosting some of those for him. I just wanted to show you, actually. I get carried away with what I'm looking at here, but I should acknowledge the fact that we had a town that was quite devastated. And one thing that I want to say, it was exciting to see a devastated town, but that we published this imagery within hours of it being available to be published. So our partner, Digital Globe, gave us this images. We tile it up, and we could serve it up pretty instantly. The other thing to point out about this is I'm cheating. I'm cheating just a little bit. I don't often use my laptop standing in front of a couple thousand people. And I don't know about you, but every time you do that, something doesn't work exactly how you want it to be. So I've preloaded everything onto this laptop. But the cool thing about that is I've got, I think this is a 100 gig drive. This data set is 20 meg. I have other data sets that go into gigs. You could have your own private database of images covering the whole Earth at whatever resolution, or for a disaster area, for example. I don't need to be online to be doing this stuff. And again, the cool thing about that is, since it's just a bunch of files, that same exact pile of files, I can just stick them on my hard drive. I don't care if it's a Linux box, a Windows box, Mac. Earth runs, of course, on all three. I can be hosting these things on an Apache server. I can host them on some fancy serving things that we use at Google. Doesn't matter. And that's, I think, is a very key point about the whole Geoweb, that it's just files. And another cool thing also is that I'm actually showing 3 levels of imagery here. I can do this radio button technique to switch back and forth between images. So again, pretty detailed images, not just a little picture, but this is actually, I really should have the resolution data, but I think it's, what you're looking at is basically about 7,000 tiles. So I'm sitting on my machine about 14,000 tiles to show this data set, and Earth roams around in it pretty seamlessly. Okay, that's pretty cool. All right, let's talk about time. Talked a little bit about how you might animate your KML. This is a pretty simple way. What you're looking at is a little hike I took apparently on January 14th, 2007. And what you're seeing is basically several hundred place marks. Each has a timestamp. And if you look on the upper right-hand corner, you'll see a little piece of user interface that Earth automatically puts up. You load a document, enable it that has time elements in it, and you get animation for free. I'm going to talk in the advanced talk a little bit about some do's and don'ts. As with lots of things in KML, it's quite powerful. If you wanted to, so we put up a little time window, which appears to be about 4 minutes here. So this is 4 minutes by 4 minutes. Here, obviously, we stood around for a while looking at the view. I myself, as the end user, can roam around in your data set in the time domain. And of course, let me just widen that time domain, time window. You wanted to see a longer time instant. Maybe you want to get a feel for how long something took. One thing you'll notice is, of course, the user can fly around in your data, while it's animating. This was done by me walking around with the GPS unit, and there's a variety of GPS tools, including Earth itself, that will suck this right in and take the GPS timestamps. That's pretty cool. Here, we'll do one. Let me just show you what's behind the scenes of time. The user has the ability to turn off the time animation, and we just have a bunch of place marks. And we're just showing you when they're valid in a time window. I think actually each of these balloons has the time. Maybe they don't. Okay. Okay, as the slide about, I like having Earth in motion. So this is a bunch of overlays, as you can see on the left-hand side. It's just a bunch of overlays. These cover the Earth, and if you look closely, you'll see that these are interestingly named ground overlays off the ground. So ground overlays, if you look in the spec, you'll see that a ground overlay can take an altitude. The other thing is that the images are transparent. And the other thing to note from a developer's point of view is if you see the time slider at the top, I'm going to stop this, you'll see that that's a time instant. So in the other data set, you've got a time window. The user could slide that, and I could do that here now too. For time spanned data, the user interface is smart and puts up a time instant. So the key concept is, and I'm going to show this a little bit more later, is if your data is imagery, you need to best use a time span, and then we sweep a stamp. We sweep a stamp through a span, and we sweep a span through stamps. If you can say that sentence, then you too can give KML presentations. Okay, I'm going to go for a couple more minutes. Share the stage a little bit. I am going to show that one later. I'm going to show .3D buildings. And everybody knows, of course, the way we got this viewpoint was with the look at tag, of course. We have a place mark with an icon, and we have this nice rendition of the 3D of the Empire State Building, which we are featuring in the AIA 150. This is America's favorite building, and here it is for your viewing pleasure. Okay, sneak peek number one. But let me say one thing first. First of all, this is a balloon, basic KML. This has rich text, as you can see, nice fonts, bold, italic. You got links. The red underlined links go fire off a web page. And I have a nice image. And there's one more little thing. So when you're viewing this 150 layer, one of my colleagues bemoaned this issue of, you got 150 points, I happen to fly down and I see number 67. Don't you kind of want to know, who beat me? Who's 66? Well, as I just showed you, I flew from item 1 to item 2. And I'm going to go into some details about what we are thinking about for the future regarding that. Those of you who have worked with some of these data sets before now realize you have a pretty powerful feature in that your user can navigate your data set without having to work on that side panel. They can roam around here. You don't have to set a tour that flies away from. They want to stop and look at this a little bit. I want to roam around this building. I read about the building. Oh, what's next? Check it out. We'll go see number 4. And notice also that the balloon popped up. That's a new thing. So we're both flying there. We're putting the balloon up. Maybe you don't want to. We'll hit stop number 5 back here at home. And I only have the top 5. But if you notice, the language down here says click to fly to number 1. In this case, we're not going to be putting up a balloon. I just fly you back to number 1. Now I'm going to try one last thing. Okay, I just showed you, am showing you now, some things we are thinking about. The other day we published a KML 2.2 beta specification that introduced a few more features. I showed you 2 of them so far. Actually, they're showing you 3 at this moment. The most interesting one of all, as far as I'm concerned, is what I'm showing you now, which is the photo overlay feature. I'm looking at a photo which has been hung in air, appropriately placed. And you can't see me, but I'm double clicking and flying into it the way you would with Earth. I'm dragging up and down to see it. And as we dismiss this photo and fly away from it, we'll see it's located in space. And I will talk a little bit in the advanced session about how you can bring in your own photos and hang them wherever you want. Okay, so on the side panel here, I have all this KML that I said I cheated and loaded. But where did I get it all in the first place? A lot of this stuff actually exists online. And that is my segue to my colleague, Lior, who is going to tell you about GeoSearch. Thank you.
Okay, so thanks to Michael and Bent, and you can think about what they describe, the cool tools, new products, and the markup language that we have as just tools to express your geo content. Now, there's many ways to express your geo content. Some are very simple. This is Angelina. You all know her. And Angelina apparently loved tattoos, and she also loved geo content. She's actually a mashup developer, sort of. So she tattooed the lat long of all her kids on her forearm, free adopted, one she gave birth to. And that's one way to express geo content. Not so efficient. It's lat long, it's pretty big. There's more efficient ways. So a more efficient way to express geo content is Michael from Prison Break. He actually encoded the entire map on his back and chest. So that's a more efficient way. But he's also expressing his geo content. So there's many ways to express geo-content. Some are, I guess, more conventional, and those are just some examples that you are expressing geo-content with. But no matter how you express geo-content, the fact is that we have more and more and more geo-content adding to the web. Michael showed the Street View example. You can imagine that we'll have even more user-annotated content from there. So the question is, where is it all going? So being in the geo world, we have the benefit of the hindsight. We can look back at where the web was a couple of years ago, because the geo world is always lagging a couple of years after the web, and sort of know where we're heading. So a bit of a Geoweb history. So the web began with a simple markup language, HTML, to express websites. And on the geo side, we have formats like KML, GML, and other formats that helps us express our geo content. Moving a couple of years ahead, to syndicate this content, we have RSS, and on the geo side, we have GeoRSS. Once you have all this interesting content, you want to show it to the users, so we invented browsers, early browsers and Earth browsers, like Google Earth that we've seen beautiful example of, Virtual Earth, Yahoo Maps, all those Earth browsers. And once you have the content and the browsers, you have tons of websites popping all over the place. So we have early websites, and we have mashups that we've all seen over the last 2 years. And when you have all those different websites start to push more and more data, you have to organize it somehow. So the early attempts that we know on the web were a directory, right? Every website sort of fits in some category, and somebody manually organizes it, sort of resembling our current state with Google Maps menu, right? You want to find an interesting mashup, you go to the category, you try to find it. But eventually, there's just too much data that could be organized in a directory, and you need a search engine. So my question is, how can we actually organize the GeoWeb, and what can we do to better deal with this data? And our answer today is GeoSearch, the search engine for the GeoWeb. So let's check it out. So I'm in Africa, and that's the regular Google Maps search box. And let's see if I can find something about Angelina that we've just came to know. Aha. So what you see on the left-hand side are the blue markers. Those are your new friends. A blue marker indicates that this is the results coming from the GeoWeb, from user content that is found out there. So those are results that we found all over the web from different KMLs, and this is where they're coming from. So most of them are coming from Keyhole, but we have also another website, and then we have Google. So let's just look at a couple of the results. So we know now that this is the famous beach that Angelina and Brett went to have the birthplace of their first child. And we actually have a news report about them leaving the beach. So we can browse through those results, but there's a Latin long in the last results. Let's click it, and we can find the tattoos. So we actually have a user that used Google My Maps, which are all indexed in the index, and prepared a mashup, a map of all the lat long that we see on Angelina. So I can browse and see all the places where her kids are. So we have a couple in Vietnam, 2 in Vietnam, 1 in Ethiopia, and the one we've seen in Namibia. So we have Angelina covered. Let's see if we have Michael. So I'll open a new one and go to Google Maps. And let's search for prison break in the US. So the red points are the local results, but we're not interested in the local results. So if we scroll down patiently, we see a new button, see user-created content, and we click on it, and we see the GeoWeb results. So there seems to be a couple of points here, but the majority of points seem to be centered around this place. Let's check it out. So if I zoom in, that's actually the original jail where they shot Prison Break. And I can get all the interesting details about Michael, including his escape plan, and including the fascinating fact that this was actually the prison where Jake from the Blues Brothers was released in the beginning of the Blues Brothers movie. So I can link to web results from the Geoweb results that I'm seeing on Google Maps. So I can actually browse and see the different facets and links that are happening there. So our magic GeoSearch box can help you locate people that were already bad guys who were already caught. But what about bad guys who were not caught yet? So I want to ask the magic box a question I'm sure you're all interested in. Osama bin Laden. OK, so he seems to be all over the place. Haha, you can find me. Dada America, shh, he's hiding there. So, those are web results. They can be all over the place, and we're just showing the data. But you have to sort of do the same process that you're doing when you're searching on a Google search box. Just listen to the most reliable source. So the Columbia University actually seems to point to Osama bin Laden here. So I'll take the word for it. So we found Osama. So except of the anecdotal queries, there are actually very serious and relevant and quality queries that we can do on your data that is just hiding out there on all the wonderful mashups that all of you are building. So let's do a couple of those. So I moved to San Francisco a couple of months ago. And the first thing I wanted to know, of course, given the fact that I'm in Google and I have a lot of beach time, is where are the windsurfing places? So I can type windsurfing in San Francisco. And again, I'm getting, those are the local results. But if I click the user generated, I'll see all the different results from the web of all the windsurfing places in the Bay Area. And that's fascinating because you can see the already existing richness of the GeoWeb. We have here results from 1, 2, 3, 4, 5 different websites. And if I'll just browse some, so there's one describing windsurfing heaven on virtual globetrotting. And then another one is actually from a site called Surf Club Sylv Plana, which gathered for me 174 different windsurfing places across the world. And I can sort of look at their data and find other cool places to surf in. And the list goes on and on and on. This was interesting. Another Google user who actually prepared a mind map and with windsurfing places around the Bay Area, and I can watch movies and do other interesting stuff all through the search results. So that's one example of local coverage. Another useful example I can do is one day my friend lent me his dog, and I had to find dogs parks in San Francisco. Another perfect query, there's no, the local coverage, or that's not the kind of data that you will find in an average Yellow Pages directory, but the users help us map the world, and we can see all the different dog parks in the Bay Area. And let's just look at one other example. And again, very useful results, including a mashup of all the dog parks near my house, including the green one with a fence and the blue one without a fence. So those queries can be very interesting for us also on the local coverage side, and especially useful if we go abroad. And I have a friend who plans a trip to Argentina, and he wanted to know what cool tango places can he find in Buenos Aires. So I did a query for him, and we're getting all the tango places in Buenos Aires. This is coming from SpyPixel. This is coming again from SpyPixel, but there's tons of information out there, and we even found the birthplace of tango over here, and we can read all the data about it. And what's interesting is think about what it means to your mashup, because another thing we can do is actually do business on transaction on those results. So another result is actually the tango hotel, the Argentina Tango Hotel, and I can actually book a place straight from the info bubble and guarantee myself a room in the Tango Hotel in Argentina. So those are just a couple of examples for what we're doing. And what we're doing, as Michael said, we're trying to organize, Google Mission is trying to organize the world's information and make it universally accessible and useful. We're trying to organize the world's explicitly georeferenced information and make it useful. But in order to make it useful and to index it, we need your help. We cannot index, we cannot bridge the gap between all your content and the index if you're using JavaScript. There's no persistent data layer. We cannot index anything. We need data to index. So if there's one thing that you remember from this session, the thing is use KML. Use KML because then we're actually able to index your data and serve your results in the search results and drive traffic your way. So use KML, and we're very happy to announce today that we're adding atom attributions, author and link to the KML spec, to the KML 2.2 spec, so you can actually specify who are the users on your site that are creating the content and where do you want us to take them when we serve the results. If you don't want to use KML for any reason, that's OK. We're very community friendly. And starting today, we're also indexing GeoRSS. So every GeoRSS that can be found on the web, we'll index it, have it as search results, and also available for you guys. The other part is actually make it accessible. And let me just demo how a GeoRSS query looks like. And that will be my last query for today. So let's find the Google Developer Day. So again, local results, non-relevant. You'll see our results more and more prominent over time, but I actually have a GeoRSS feed now in the index coming from upcoming.org by this user that I can click through and actually see the page as it was on the GeoRSS feed from upcoming. So that's one way to do it. And as you all well know, we changed the location kind of the last minute. So upcoming didn't update the location, but there was a Google My Maps user that updated the location to be actually in San Jose and have the entire itinerary and the session. So that's, again, another useful example for how can you use GeoSearch. So what do you need to do to get in our index? You need to do 3 simple things. You need to use KML or GeoRSS in your Maps API. You need to put it in a public server so we can crawl it. And you need to inform us in a sitemap that we can actually find the KML or GeoRSS if you want to help us index it properly. And if you don't, and for some reason you don't want us to be called, we'll always respect the old conventions of not calling your content. If you want more information on how to get your content indexed, just come for the 4:30 session on GeoSearch and developing maps mashup using KML and GeoRSS. You can find more documentation on the web and how to get your content indexed. And hopefully, if you'll do all of this, you can be a part of the Geoweb. And that's actually a pretty amazing picture. That's the first snapshot of the Geoweb as we know it today. And what you see there is every red point is a point that we have currently in our index of geo content. And apart from sort of looking and seeing where the urban places and when the developing countries, you can see lots of interesting stuff. You can track the Amazon routes. You can see underwater currents in the ocean. And if you wondered what are those lines, those are actually KML network links describing popular flight routes to Hawaii or over the Atlantic. So only when you actually look at this picture, I think you can start to imagine the possibilities and the future that we're creating together. Thank you.